Hello everyone, welcome to the today's LeetCode Contest 471. Today we will be discussing the solution for the problem 192. The first problem is, let's read out the problem once. Sum of elements with frequency divisible by k. You are given an integer array nums and integer k. Return an integer denoting the sum of all elements in nums whose frequency is divisible by k, or 0 if there are no such elements. An integer is included in the sum exactly as many times as it appears in the array if its total frequency is divisible by k. The frequency of an element exceeds the number of times it occurs in the array. Let's dry run the first test case here. So initially we will be given this integer array nums and a k. We have to find all the frequency of the each number. Let's see how we need to find the frequency of all the elements. Let me write the frequency. There are the four elements, one, two, three, four. The frequency of the first element is 1, so frequency means count of the number in the given array, and frequency of 2 is 2, frequency of 3 is 4, frequency of 4 is 1. You can see that we just need to concern about the frequencies whose division number, yeah, it's 1, whose frequency is divisible by k. So if you can divide with k, it will not divisible. So 2 divisible by k, yeah, it's divisible by k. 4 divisible by k, it's true. 1 cannot divisible by k. We'll just concern about these two frequencies of these numbers, like 2 and 3, right? Because you can see that the frequency of 2 is divisible by k and frequency of 3 is divisible by k. You have to add all the frequency of into sum. So let me declare this sum is equal to here. I need to add all these values. 2 is added two times, right? 2 into 2 plus 3 is added four times, because you can see that for 3 is appeared four times. So we need to add all the frequencies. So this is how I can simply multiplying the number into the frequency, right? You can see the sum is 4 plus 12, it is 16. Right? This is the answer for this first test case. So yeah, this is a simple easy problem. You can see a single traversal will be required to count one traversal for the counting the frequency of the each number, and the in the second traversal what you can do is that for each carrier each number, check that if the frequency can be divisible by k. If it is divisible by k, simply add this into your answer. Yeah, let's see the code. So yeah, its main thing required to do this question is to just process the frequency of each number into the map, or you can take the any frequency area also, it's okay. First take the map and store the frequency of each number. Here there are four numbers. I will be storing the frequency of each number 4241, right? After processing all the frequencies, in the second traversal, what you can do is go on traverse the map and check if the frequency is divisible by k. If it's divisible by k, what you can do, simply multiply that value into count. Count means number of frequencies. Let's see the code. Yeah, this is a code which I actually have used the map here. So you can use the frequency array or some other things also you can do. There are a lot of ways to do this one. Initially I processed all the frequency into my map. I will be traversing the map, right? I have got the number, so that is a key which I stored as a in the map, and count is the value that is stored frequency. So if my frequency is modulo k is equal to 0, what I can do, so simply I added the number of frequency of that element into my sum. So this is how this many times this number has occurred, this count number of times into my integer array nums. So if you can see the time complexity, the time complexity is big O of n here, because we are processing all the elements. Here big O of n plus, here also we are in the worst case we are traversing the big O of n times, right? So at the last you can see that this boil down to the big O of n. So you can see space complexity, we are using the extra space here. So that is map, we are taking big O of n space. Okay. Yeah, this is all about the first question. Let's move to the second question. Yeah, let's read out the second question here. So the question is the longest balanced substring. So you are given a string is consisting of lowercase English letters. A substring of S is called balanced if all distinct characters in the substring appears the same number of times. Return the length of the longest balanced substring of S. A substring is a contiguous non-empty sequence of characters within a given string. So let's take this is a string given. So the size of the longest substring is 4, which is balanced. So the balance is means that the frequency of all these or the occurrence of all these characters should be same. Either it should be any number of times it should occur. So all these should occur exactly same number of times. And yeah, that's a question what you're. We can see the question right in the test first test case here. A, B, B, A, C, right? You can see that the frequency of A is 1, 2, yeah, A is 2, B is 2, and C is 1. You can see that this is a contiguous part of the R string. So we can say that this is a substring, right? You can if you can see that this is a substring which is having equal number of frequency, right? So this is what it actually asking about the uh, the substring, the all distinct characters means all the characters in the substring appears the same number of times. You can see the two A is occurred two times, B is occurred two times. You can count it as 4. So if you could take this C here, it is doesn't satisfying condition, because you should require the frequency 2 here if you just want to add into the previous answer. If you let's see the what is the constraints also here. In this question, I think the yeah, the constraints are very less because we can do brute force on this question. Yeah, let's see how we can do the brute force. Initially, what I can do is just I just want to try run. I will take another test case, different test case here. Let me take yeah, I will take, yeah, just go with the first test case. Let me erase it out. So the brute force idea is that generating all substring, that's kind of approach you will follow here. The brute force is you can do all the generate all substring in the big of n square if you don't want to store that one. So if you want to store, you can have to be extract the complete substring into your answer. So here we don't want to extract or you want to print here something else. So we just want to process some process and just find the length here. So we are just concerned about this one. So let's see how we can do that. A, B, B, A, C. So if I put my eyes, let me give the index in here 2, 3, 4, right? So when my I is equal to 0, I can go for I will start my j is equal to I will start my j from I, and I will go 1, 2, 3, 4, right? So what types of substrings we have saw here? So it should be 0, next 0, 1, right? um yeah, we are looping the j from the 0 to last. It means that we covered this a b b a c, right? When we are calculating the each, yeah, let me process it clearly so that, so when I is equal to 0, you can see j is going from 0, 1, 2, 3. So each time I will be simply increasing the maintaining the frequency of each character into the way 26 characters. I can use map or I can use the frequency array, right? We can see when my j is equal to 0, a is here, my j is 0 here. It means frequency of a is 1. I will moving my j here, the frequency of b is 1. Yeah, let me process the answer also. While I am doing this each iteration of the j, I just want to process my answer also. Yeah, we will do after the iteration, first iteration. So how we can doing all these things, right? In the second thing, what you can do is that the second yeah, we got the b is equal to 1 here. So initially, yeah, we'll go through this. Next, my j is got here. That is again b got 2. Again, my j is here. So a got 2. You can see that this is the case we actually want. This is our answer. So simply, I will be having the simple vector of 26 characters, which is storing the vector, or you can take the array. So which is storing the frequency of all the characters from the a to z. right? um, yeah, I will be representing each letters as a from zero indexing, so I will be change them into the indexes. Yeah, yeah. Let's see. Yeah, we got that answer. I can again. I will be moving my J to the C. So when my C count has got one, so it's not possible because you can see that all the frequencies are not same, right? This is how we can process all the substrings into the in the way applying the brute force approach here. Each while um, maintain the frequency on each iteration, we will just want to process that substring, right? So initially we got A here, next we got AB here, we got ABB here. So these are the all possible substring which can form with A, right? Let me write here clearly so that it could be more helpful for you. Initially, when I is equal to 0, there would be AB, ABB, ABBA, ABBAC, right? So these are the possible substring which can form with I is equal to 0. So when I can move I is equal to 1, I can process all the substrings from I 1 to the last. That means I can have B, BB, B, BAC, right? When my I is equal to 1, 2, again I can form all the substring which can start with the B again. So when I is equal to 2, you can see that B, BA, BAC, right? Yeah, it's a brute force approach to generate all the substrings. So when I is equal to 3, you can see A and AC, there are two possible. When I is equal to 4, you will be having only C. So while processing all these substrings into this inner loop, so we'll just maintain the frequency of these complete things into our 26 characters frequency array or frequency map. I will be simply, so let's see, it will be more understandable if you can see the code. Yeah. So the outer loop is just meant to check that all the possible substrings starting with each I, and inner loop is going for all these characters which can able to form these substrings, right? um yeah, let me do one thing here that when I is equal to 0, I will be processing all this, I mean that all these substrings. Let's say I is equal to 1. When j is equal to 0, I will be simply updating the frequency of that a, and after updating the frequency of a is equal to 1. So I will be simply traversing this frequency map for each iteration of the j, and I will be checking that is all the characters are having the same frequency or not. Let me write it here. Yeah, I can have this one, right? So initially my I is, when j is equal to 0, I is 1, all they are 0 here. So how we can check that all these characters or all these letters are having the same frequency? The idea is very simple, that if you could find the minimum frequency and maximum frequency, if they are equal, it means that all this frequency are, or all the frequency of all the characters in the same. So this is how we can you check that if the all the letters are having the same frequency or not. For j is equal to 0, j is equal to 0, we got a frequency of a is 1. When I'm moving my j to 1, you can see that the frequency of, as I am moving forward in the j to the next iteration, I will be update my answer here. So if the frequency of all the characters are same, that means if maxi is equal to mini, means minimum and the maximum frequency is equal to, means then then I could say that the all the elements are equal. Then I will be simply update my answer is equal to max of, I will take max of answer comma max of answer comma how we can find the length of the substring. So that's the thing we need to discuss here. So the length of the substring is very simple here. Length is equal to, so the left pointer, that is j minus I plus 1, right? So J is always a right point. I mean, a right pointer. I is a left pointer that is pointing to this index, right? And J is going traversing and finding all the possible substrings here. So if it could find the satisfied condition, that means if these found the um, that equal number of frequency of the characters, then it will be simply updating the answer here. If you could see the code, that would be more, you can get more idea about this question. You can see that yeah, it took me some, yeah, you can see that initially I will be trying out all the possible substrings here, starting with each character or each index, right? I will be having the frequency, the vector that is having 26 characters. I'm trying out all the possible substrings. When I'm processing a single substring, here you can see that I am updating the frequency of the substring, and I will be maintaining took the two variables here. You can took the maxi and minimum here. It's more meaningful there. If this would be indicating the minimum frequency in the this 26 vector frequency here, and the second is indicating that it would be the maximum, or what I can say, it's a maximum frequency of the letters in the given vector. I will be processing or I will be traversing the 26 characters in the vector, and if I could found the, if frequency is greater than 0, then only we should be update the answer. Otherwise we don't need to update, because if frequency is 0, it doesn't matter to us, right? You can see if the frequency or the maximum and minimum frequency that is equal, then I would be simply updating my answer. This is how we can find the length of that answer. So at the last I am returning the answer. You can see that so this is the loop which is mainly, this is the outer loop is mainly focusing on the substring switching and start with I. This inner loop is completely generating all the substrings. So this is a brute force idea of the finding the all the substrings, and we simply processing the all the substrings by maintaining the frequency here. Yeah, the, you can see the time complexity of this code is you can, that is big of n square definitely, because we are running the loop here two times. There is another loop running inside this. This is also going in the worst case big of n times, and inner loop is going for 26 characters. This you can see that this is the loop which is traversing for 26 characters. I will simply do 26 here, and we are also using a space here, and space complexity is big of I would say we are using frequency vector that is 26, right? So this is all about the second question. Yeah, thank you for watching.